Hey, this person asked a question here, and I thought it was a good one, maybe to talk to for other people as well. And so this is, I believe this is like the free form number 3 from quiz 3 practice, just so you can find it if you need it. But basically, the question was, how do I know when things are in series, when things are in parallel? And when you're doing these problems, this is key, especially on an example like this, where whoever drew this, right, drew it purposely to be mean and confusing. And so our rule is, and this is what I use myself when I'm trying to figure these out, right? You can maybe make up your own rule, but my rule is, so for series, for two things to be in series, what that means is if I go through the first one and I keep going, I have to go through the second one. There's no other choice. For parallel, what it means to me, and this one is a little more flexible, but basically, so here's two resistors. To be in parallel, it means I can go from the top of one to the top of the other without hitting anything else but wires, and so I can do that here, and I can go from the bottom to the bottom without anything else but wires. And so on this particular problem here, okay, starting out, the two ones that are sort of key is this 3 and this 6. And if you look at it, it sure looks parallel to me, right? But that would be the person being a jerk. And so to be parallel, you've got to go from the bottom to the bottom, the top from the top. So let's just say I can go from this side to this side without touching anything else. So that's promising. However, if I try to go from the other side, I either bump into this or I bump into this. So these are not in parallel by our strict definition. So just because they look like they're parallel doesn't mean they're in parallel. And so let's look at this. If I look at this particular case here, if I go through the 6 and keep going, then over here I have to go through the 3. So this is the case where they're in series. What also can help is just sort of redrawing the picture, right? So here's this 8 microfarad capacitor, and this guy, it was drawn all crazy like, but I can just sort of draw it like this just to make life easier, right? And then over here, if you draw these sort of this way, like, if the problem had been structured this way, right, it's a little bit clearer how to do it. So you have the freedom to redraw these things. And when you redraw them, the way you make sure that they're drawn correctly is just sort of what I was talking about. Make sure the pieces can touch. Like here, right, the way this was drawn, I could go from one side to the other side without touching anything else, but I can't go the other one. And so I get stuck, right? And so you can see that it's got the same sort of characteristics as the other one. So basically what you would do is you would combine these two as series capacitors and then kind of go from there. But the trick is, sort of getting to the point where you're confident enough to know that. And so these are the two rules that I use. And like I said, sometimes drawing a picture can help, but really the best way is just to get lots of practice and trying different examples.